Welcome to the free body diagram video. This is in chapter 4, and we're going to be doing a lot of these in class. Every time we do a problem that involves forces, we have to talk about a free body diagram. The free body diagram is a representation of all the forces that act on an object, and we represent the forces as arrows because they're vectors, and they point in a certain direction, and the size of the arrow can indicate the relative size of the actual force. So some of the more common forces that we have on free body diagrams are listed on the board. Almost everything has weight, unless we're talking about being in space or something. So weight we represent with a capital W. Sometimes we use a lowercase m and a lowercase g, and we'll talk about why we do that in class. And it's always directed downward toward the center of the earth. So if something is sitting on a desk or you're sitting in your chair, that kind of makes sense that your weight is straight downward toward the center of the earth, but it's still that way if you're on an incline. So if you're standing on a ramp or you're standing on a hill, your weight still acts directly downward. It's the force of attraction between you and the earth, and so you're going to draw it that way on the free body diagram. N is for a special case. N is for when you have something on a surface. So if you're sitting in your desk right now, or you're sitting someplace at your house, your weight is going down, and there's something called a normal force pushing up on you. The normal force can be caused by the floor, it can be caused by the chair you're sitting in, but it's always going to be perpendicular to the surfaces, because that's what normal means. In math class, normal means perpendicular. So the normal force is always perpendicular to the surfaces. Another one that is common is friction. Friction is going to oppose motion. So friction is a force. It's also measured in newtons like all the rest of these are, but it's going to oppose the motion. So if something is moving to the right, then friction is going to act to the left. And it's always going to be parallel to the surfaces. T is a special force, and it's only going to be on an object that is tied to a rope or a wire or a cable. It stands for tension. All of these things are going to be measured in newtons because they're all forces. So when you want to draw a free body diagram, what you do is you either draw a dot or you draw a box. And when you're drawing the dot or the box, that represents what the object is. So that could be a car, it could be a football, it could be a squirrel. It doesn't matter. Everything will be drawn from that dot or from a box, and it'll be directed away from and in the direction that it's indicated. So if we're talking about a box sitting on a table, a box sitting on a table is always going to have a weight down. And we label that with W. And then if it's sitting on a table, that means that the table is also pushing up on it. And so you would draw a normal force to oppose the weight, and it's going to be perpendicular to the surfaces. So that's the free body diagram for a box sitting on a table, or a book sitting on a table, or for that matter, you sitting in your chair. Your weight is down and the normal is up. If you had something on an incline, we draw an incline as usually a right triangle. So if we have an incline, say a car is parked on a hill. If we have a car parked on a hill, usually we draw cars as boxes, so it's sitting on the hill. And then from the center, that's where we're going to draw all the forces that act on this car sitting on a hill. So the weight acts straight down towards the center of the earth. That's the weight. The normal force acts perpendicular to the surfaces. Well, this is the surface, perpendicular to that. That's the normal. And then there's also friction. Friction is what helps keep the car on the hill from sliding down. So since the car wants to slide down the hill, friction is going to act opposite of that, and it's going to be parallel to the surfaces. So if you have a car resting on a hill, this is the free body diagram for that. If we had a chandelier in our house, we have a light hanging from a rope. Here's the light. The weight is down toward the center of the earth. The tension, there's no normal because there's no surface. This is a chandelier, but there's going to be a tension upward caused by the rope keeping the chandelier hanging up. So this is how we do free body diagrams. You just have to get used to labeling the way that everybody labels them. W for weight, F for friction, T for tension, N for normal. So you're going to have something to practice on your own. Gotta walk around.